Did you know that 95% of the universe is made up of things that we cannot see or fully understand? That's correct. Dark matter and energy are completely invisible but control almost everything in space. And that's just the tip of the iceberg when it comes to cosmic mysteries. Today, we're looking at some mind-boggling questions in space that no one has been able to answer. Welcome to Questions That No One Could Find Answers To, Space Edition. 1. What caused the Big Bang Theory? All right, folks, let's talk about the Big Bang. No, not the TV show. I'm talking about the most mind-blowing theory on how our universe started. You know, the one that explains everything from stars and galaxies to, well, us, sitting here watching YouTube videos. So how exactly did it all go down? Well, imagine this. 13.8 billion years ago, yes, billion, the entire universe was squished into a teeny-tiny point. And I mean tiny. We're talking smaller than a pinhead, like you could have fit the whole universe into your pocket. No kidding. But here's the kicker. This little speck wasn't empty. It was jam-packed with crazy amounts of energy and matter, all jumbled together in a superheated, super dense ball of chaos. And get this, it was so hot that if you were somehow standing there, which for obvious reasons you weren't, your eyeballs would have probably evaporated just from the heat alone. It was hotter than a summer day in the Sahara, but on a galactic scale. Now, here's where it gets wild. At this point, the universe as we know it didn't even exist yet. No stars, no planets, no anything. Just one incredibly dense hot mess of energy. The laws of physics? Yeah, those didn't apply the way we understand them today. It's like trying to play a game of basketball with no rules, except the ball is on fire and it's about to explode. So what happened next? Then something absolutely mind-blowing happened. A point holding all the energy in the universe suddenly expanded, and fast. I mean, way faster than the speed of light. But this wasn't an explosion like we usually imagine. No big fireball. Instead, it was the space itself that started expanding. This incredible event is what we now call the Big Bang. In the moments right after the Big Bang, the universe began to cool down and spread out. But it didn't happen all at once. Oh no, it happened super quickly, just fractions of a second. During that tiny window, space itself started to stretch and grow. As it cooled, tiny particles started to form. First came the basics: protons, neutrons, and electrons. These little building blocks would go on to form everything we see around us today. And guess what? The universe is still expanding. The galaxies, stars, and planets we see, they're all the results of that rapid expansion that happened at the very beginning. The Big Bang wasn't just the start of the universe, it was like the ultimate kickoff party. But what's even more fascinating is what happened right after. In the blink of an eye, the universe went through something called cosmic inflation. Imagine space stretching out so fast it would make the speed of light look like it's stuck in traffic. In less than a fraction of a second, the universe expanded billions of times over. That's right, billions. One moment, it was tiny. The next, it was like it hit the cosmic jackpot and decided, why not go big? But this wasn't just a random growth spurt. This rapid expansion smoothed everything out, ironing out the chaos and setting the stage for the galaxies, stars, and planets we see today. So yeah, cosmic inflation, pretty much the universe's way of laying a solid foundation for, well, everything. But during this time, the universe was unimaginably hot, trillions of degrees hot. It wasn't filled with stars or galaxies yet. Instead, it was a chaotic soup of energy, where particles like protons, neutrons, and electrons didn't even exist yet. This era is often called the primordial plasma. As the universe continued to expand, it also cooled down just enough for energy to transform into particles. This is when things got interesting. Protons and neutrons started to form within the first second. These are the building blocks of matter, and without them, atoms and everything else in the universe couldn't exist. By the time the universe was about 3 minutes old, it had cooled down enough for these protons and neutrons to stick together, forming the first atomic nuclei. This process, called nucleosynthesis, created the earliest elements like hydrogen and helium, which make up most of the universe even today. As the universe kept expanding and cooling after the Big Bang, something amazing happened. Light and atoms were born. This was a big moment in the universe's story. About 380,000 years after the Big Bang, things finally cooled down enough for protons and electrons to join forces and form the first neutral atoms, mostly hydrogen and helium. Scientists call this process recombination. Before this, the universe was basically a hot, thick fog of charged particles. Light couldn't move freely, it just kept bouncing around like it was stuck in an endless cosmic ping-pong match. The result? A dense, opaque soup that hid the universe's glow. When the universe cooled down to about 3,000 degrees Kelvin, basically when things went from molten lava hot to just ridiculously hot, protons and electrons started playing nice and teamed up to form atoms. With fewer free electrons causing trouble, light was finally able to travel freely across the universe without being constantly bumped around like a pinball. This was the big moment when the universe became transparent, letting light spread out and fill the vast emptiness of space for the very first time. That same light, stretched out over billions of years thanks to the universe's endless expansion, is what we now see as the cosmic microwave background, CMB radiation. Yep, it's the universe's baby picture, still glowing faintly in the background. It's like a photograph of the baby universe, still visible as faint microwaves coming from all directions in the sky. The CMB is one of the most important pieces of evidence for the Big Bang theory. It was discovered accidentally in 1965 by scientists Arno Penzias and Robert Wilson, who won a Nobel Prize for their work. This glow is essentially the afterglow of the Big Bang itself. This era of light and atom formation set the stage for everything that would come later: stars, galaxies, planets, and eventually life itself. It was the beginning of the structure of the universe. The Big Bang Theory gives us a pretty good idea of how the universe started and grew into the massive cosmos we see today. It tells us that space, time, matter, and energy all came from one tiny point. Sounds neat, right? But here's the kicker. We still have no clue what caused it. Scientists have pieced together what happened right after the Big Bang, but the exact moment it happened, the singularity, is still a complete mystery. Why? Because at that point, the laws of physics just throw their hands up and quit. Gravity goes off the charts, space and time collapse, and we simply can't explain what's going on. It's like the Big Bang is playing hide-and-seek behind a curtain we can't pull back yet. And that leaves us with some of the biggest brainbusters in science. What set off the Big Bang? Why didn't the universe just stay at that tiny point? And where did all the energy and matter even come from? It's the ultimate cosmic cliffhanger. These are questions we may never fully answer. The further back we look, the more the answers seem to slip through our grasp. Is the Big Bang the absolute beginning of everything? Or is it part of a larger cosmic story we don't yet understand? Like a multiverse or a cyclical pattern of creation and destruction. Science has theories, but none can fully explain what happened before the Big Bang, or if before even exists. This is why the Big Bang Theory is both fascinating and unanswerable. It tells us so much but leaves us yearning for more. And maybe that's the beauty of it. Some mysteries push us to keep exploring, learning, and expanding the boundaries of human knowledge. But now, here's the next big question that nobody could find the answer to. 2. How will the universe end? Every beginning has an end. And yes, even the universe isn't getting a free pass. But here's the thing. The end of the universe is one of the biggest, weirdest, and most mind-boggling mysteries out there. Scientists say it won't happen for billions or even trillions of years, so don't start packing your bags just yet. Now, how will it all go down? Will the universe slowly fade into darkness like a dramatic movie ending? Will it suddenly collapse like a bad souffle? Or will it be something so wild we can't even imagine it? Nobody knows for sure, but scientists have been puzzling over this for decades. What we do know is that the fate of the universe depends on a cosmic tug-of-war between two forces: gravity, which likes to pull everything together, and dark energy, which keeps pushing the universe apart. Which one will win? Well, that's the ultimate plot twist we're all waiting for. Right now, the universe is expanding. Galaxies are drifting farther apart as space itself stretches. But here's the big question. Will this expansion keep going forever, or will it stop someday? The answer depends on a cosmic tug-of-war between two forces: gravity and dark energy. There are three big ways this could all end. First, the big freeze. The universe keeps expanding until everything gets so far apart that it becomes cold, dark, and, well, pretty lonely. Second, the big crunch. Gravity wins, pulling everything back together until the universe collapses like a deflated balloon. And then there's the big rip. Dark energy goes wild, tearing apart galaxies, stars, and even atoms. The universe might end with a bang, a freeze, or a cosmic tantrum. Let's talk about the Big Freeze, also known as the heat death. Sounds pretty dramatic, right? Well, it's one of the most likely ways the universe could end. In this scenario, the universe keeps expanding forever. But here's the kicker. As it gets bigger, it gets colder, darker, and emptier. Let's put it this way. Imagine galaxies slowly drifting farther apart, like distant relatives at a family reunion who just can't be bothered to hang out anymore. Stars, including our beloved Sun, will burn out when they run out of fuel. With no gas and dust to make new stars, the universe enters what scientists call the star death phase. Over trillions of years, most stars will either turn into cold, dense remnants like white dwarfs or collapse into black holes. So yeah, it's not the most exciting ending, but at least we've got trillions of years to go before that happens. But it doesn't stop there. Even black holes will eventually die due to a phenomenon called Hawking radiation, which causes them to lose energy over billions of years. Once all black holes evaporate, the universe will consist of nothing but scattered particles and radiation, floating in a near-frozen void just above absolute zero, 273.1 degrees C. At this temperature, there isn't enough energy for any activity or life to occur. It is also said that the Big Freeze could take around 100 years, that's a 1 followed by 100 zeros, to fully unfold. This unimaginable timescale is why it's referred to as the long goodbye of the universe. While the Big Freeze is a slow and peaceful end, not all theories about the universe's fate are so calm. Enter the Big Crunch, where gravity steps in and flips the script. If the Big Freeze is the universe's quiet exit, the Big Crunch is like the universe saying, "Okay, enough of this expansion stuff," and goes out with a bang. Here's the theory. Instead of endlessly stretching out, the universe could one day stop expanding and start collapsing. Everything would get squeezed back into a single point. So, how does this happen? Right now, the universe is expanding, thanks to dark energy. But what if dark energy isn't strong enough to keep the expansion going forever? If gravity eventually takes charge, it could pull everything back together. Galaxies would slow down, stop running away, and start moving closer. Over time, the universe would shrink, getting hotter as all the matter gets packed into a smaller and smaller space. Basically, a cosmic squeeze. As the universe contracts, stars, planets, and even black holes would collide and merge, creating unimaginable chaos. The temperature of the universe would rise to extreme levels, undoing all the cooling that happened after the Big Bang. Eventually, everything would be crushed into a single, infinitely dense point, much like the singularity at the beginning of the universe. This theory mirrors the Big Bang in reverse. Some scientists speculate that if the Big Crunch happens, it could lead to a new Big Bang, creating a cyclical universe that expands and contracts endlessly. Although current evidence favors an accelerating universe, making the Big Crunch less likely, it's still a fascinating possibility. But there's one more scenario that's even more terrifying. The Big Rip, where the universe doesn't collapse, it tears itself apart. Let's dive into that in the final part. The Big Rip is the universe throwing a tantrum. According to this theory, the universe's expansion won't just keep going. It'll speed up until everything, even space itself, gets ripped apart. Right now, dark energy is the culprit behind this expansion, though we don't know what it is yet. If dark energy gets stronger over time, it could push galaxies, stars, planets, and even atoms apart faster and faster. In the end, dark energy could overpower gravity, electromagnetism, and even the forces that keep atoms from falling apart. It's like the universe saying, "You know what? I'm done with all this." In the final moments of the Big Rip, galaxies would fly apart, stars would disintegrate, and even molecules would unravel. The universe would become a chaotic, structureless void. Unlike the Big Freeze or the Big Crunch, this scenario is absolute. Everything would be destroyed. If the Big Rip happens, scientists estimate it could occur in about 22 billion years, depending on how dark energy behaves. But this remains highly speculative since dark energy itself is still a major mystery. So, how will the universe end? The truth is, we don't know. The answer depends on a lot of things we don't fully understand, like dark energy, and whether its effects will stay the same, get stronger, or fade away. The end of the universe is still a mystery because we're just beginning to scratch the surface of the cosmos. All we can do is observe and guess based on what we see happening now. But what the future holds, that's still a big question mark. And honestly, the humbling part is knowing we're asking about something that could happen billions or even trillions of years from now. The universe is huge, its timescales are mind-blowing, and its mysteries, well, they seem endless. If we can't yet answer how the universe will end, it raises another unanswerable question. Are we alone in the universe? Could there be other intelligent life out there, wondering about the same mysteries as us? 3. Are we alone in the universe? Are we alone in the universe? It's one of the biggest questions we've ever asked. For thousands of years, we've gazed at the stars, wondering if there's someone or something out there asking the same thing. The universe is so huge, it's hard to wrap our heads around it. There are hundreds of billions of galaxies, each packed with billions of stars, and around many of those stars, we now know, are planets, called exoplanets, some of which might have conditions similar to Earth. So far, we've discovered over 5,000 exoplanets, and a few of them are in the habitable zone, that sweet spot where liquid water could exist. Sounds promising, right? Maybe we're not alone after all. Given these staggering numbers, it seems almost impossible that Earth is the only place where life exists. But despite decades of searching, we still have no definitive evidence of life beyond our planet. Scientists have been using powerful tools like the Kepler Space Telescope and the James Webb Space Telescope to identify exoplanets that could support life. In our cosmic backyard, missions to Mars and moons like Europa and Enceladus are on the hunt for even the tiniest signs of life, like microbes. But here's the catch. The universe is huge. So if life does exist out there, could it be intelligent? For decades, scientists have been on a quest, searching for signs of civilizations way beyond Earth. And this search isn't just about finding water or tiny microbes. It's about hoping we find other beings asking the same question. Are we alone? Pretty wild, right? One of the most famous efforts in the search for alien life is the Search for Extraterrestrial Intelligence, or SETI. SETI uses powerful radio telescopes to scan the skies, hoping to catch a signal from intelligent life. These signals could be anything from radio waves to other types of communication, either sent on purpose or by accident. So far, we haven't found anything conclusive, but we've had some exciting moments, like the WOW signal in 1977. It was a mysterious burst of energy that still had scientists scratching their heads. Another method scientists use is looking for technosignatures, signs of technology left behind by an advanced civilization. This could include massive structures around stars like Dyson spheres or weird light patterns that suggest someone is using a lot of energy. Earth itself sends signals into space. Since the early 20th century, human radio and TV broadcasts have been traveling outward, creating a bubble of signals about 100 light-years wide. But here's the problem. The vastness of space makes finding intelligent life incredibly difficult. A civilization could be billions of light-years away, or they might communicate in ways we don't yet understand. While the search for intelligent life often steals the spotlight, many scientists believe that the first evidence of extraterrestrial life will come in a much simpler form: microbes. These tiny organisms, similar to bacteria on Earth, might be far more common in the universe than in advanced civilizations. Our solar system is a great place to start the search. Planets and moons like Mars, Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, are prime candidates. Why? Because they show signs of having liquid water, an essential ingredient for life as we know it. For example, Mars has polar ice caps and evidence of ancient rivers and lakes, while Europa and Enceladus have subsurface oceans beneath thick layers of ice. NASA's Perseverance rover is busy on Mars, collecting rock samples that could hold fossilized evidence of ancient microbial life. Meanwhile, future missions are set to explore Europa and Enceladus, moons of Jupiter and Saturn, where they'll probe icy surfaces and check out water plumes for signs of organic molecules. Back in 1996, scientists found a Martian meteorite in Antarctica named ALH84001. It had structures that looked like fossilized microbes. While there's still debate about it, this discovery got people excited about the possibility of life beyond Earth. Finding even the simplest life form out there would be huge. It would show that life isn't just a one-off miracle here on Earth, but could happen under the right conditions. The only problem? We still don't have solid proof. So the big question remains, is life super rare, or are we just not looking in the right places? First, we have to know that the universe is too vast. Light, the fastest thing we know, takes over 4 years just to travel to the nearest star, Proxima Centauri, and it takes 100,000 years to cross our galaxy. Even if intelligent civilizations exist, they might be so far away that their signals haven't reached us yet. Or worse, we may not recognize them if they have. Second, life is fragile and fleeting. Civilizations might rise and fall in the blink of a cosmic eye. It's possible intelligent life exists but has already disappeared, or it's not yet advanced enough to communicate. We could also be looking in the wrong places or for the wrong signs. Finally, we don't even fully understand how life began on Earth. If life requires very specific conditions, it might be incredibly rare. But if it thrives in unexpected environments, as extremophiles do on Earth, life might be everywhere. In the end, the question isn't just about life out there. It's about understanding our place in the cosmos. For now, are we alone is an unanswerable mystery, but one that inspires us to keep exploring, learning, and dreaming. Moving on to our next mystery. Is there a planet X? 4. Is there a planet X? Astronomers are like detectives solving the mysteries of the universe. Over the years, they've discovered 8 planets in our solar system, Mercury to Neptune. But what if I told you there might be a 9th one lurking in the shadows? Like a cosmic ninja? Welcome to the saga of Planet X. Planet X isn't a recent idea. It dates back to the 19th century when astronomers noticed something strange. Uranus and Neptune, the outermost giants, weren't following their expected orbital paths. Their movements hinted at a hidden gravitational pull, possibly from another massive object, an undiscovered planet. This sparked a treasure hunt for what people romantically called Planet X. Before you rush off to grab a telescope, here's the twist. Pluto was discovered in 1930 while scientists were on the hunt for Planet X. But surprise, Pluto turned out to be way too small to explain the gravitational effects they were seeing. Oops! So, while Pluto got its moment of fame, the mystery of Planet X remained unsolved. Fast forward to today, and modern astronomers think Planet X, or Planet 9, as it's now called, might be chilling way out beyond Neptune in the Kuiper Belt. This region is full of icy objects, but Planet 9 is playing hard to get. So, is it out there? Or is it just a cosmic wild goose chase? Why do scientists still believe in Planet X? Well, it's not because they love a good mystery, though who doesn't, right? The real reason is the strange behavior of distant objects in the Kuiper Belt. These icy bodies, sometimes known as trans-Neptunian objects, have orbits that don't make sense unless something massive is lurking nearby, pulling the strings. Astronomers Konstantin Batygin and Mike Brown reignited the Planet X conversation in 2016. They studied these Kuiper Belt objects and noticed their orbits were clustered like dancers pulled toward an invisible partner. According to their calculations, this partner might be a planet about 5 to 10 times the size of Earth, orbiting far beyond Neptune. And get this, if Planet X exists, its orbit would be so gigantic that it could take 10,000 to 20,000 years to complete a single trip around the sun. That's like the cosmic equivalent of waiting for the next season of your favorite show, times 10,000. Still, the search is tricky. Planet X would be incredibly faint, hidden in the vastness of space. It's like trying to spot a single firefly in a pitch-dark forest. But if we do find it, it would rewrite what we know about our solar system. Hunting for Planet X isn't as easy as pointing a telescope and yelling, "Found it!" The outer solar system is huge, like really huge. If Planet X exists, it's ridiculously far away, hundreds of billions of kilometers from the sun. At that distance, sunlight is so weak that the planet barely reflects any light, making it almost impossible to spot with Earth-based telescopes. And if it's moving slowly across the sky, well, that just makes it the universe's hardest game of hide-and-seek. But technology is catching up. Powerful telescopes like Subaru in Hawaii are scanning the skies, looking for faint, distant objects. Astronomers are also using computer simulations to predict where Planet X might be, narrowing down the search area. Still, it's not a quick process. This isn't like spotting Jupiter on a clear night. It takes patience, precision, and a bit of luck. And let's not forget the skeptics. Some scientists argue that the peculiar orbits in the Kuiper Belt could be caused by other factors, like interactions with a passing star millions of years ago. After all the theories, calculations, and endless scanning of the cosmos, one question still hangs in the air. Why hasn't anyone definitively found Planet X, or proved it doesn't exist? Well, the search itself might be the biggest mystery. The real challenge? Space is huge and dark. It's like trying to count every grain of sand on Earth's beaches, but the grains are scattered across billions of kilometers, and most are too small or too faint to see. That's the scale astronomers are working with. Even with fancy telescopes and simulations, Planet X could still be hiding out there for decades. Why? Because it's so far away and so dim. And there's another issue: time. If Planet X is real, it orbits so slowly and so far from the Sun that it barely moves compared to the stars around it. Talk about taking the scenic route. This makes it incredibly hard to spot, especially when telescopes need to sift through countless other objects in the Kuiper Belt. Combine that with the limits of our current technology, and you've got a riddle that even the best astronomers struggle to solve. But perhaps the most intriguing reason this question remains unanswered is human curiosity itself. The possibility of Planet X lives on because it represents something more than a planet. It's a reminder of how little we know about the universe. Whether we ever find Planet X or not, the pursuit itself inspires us to keep exploring. So, is there a Planet X? For now, it's a cosmic maybe. But isn't that the beauty of space? It keeps us asking questions and looking to the stars for answers. One day, we might discover it, or we might uncover something even more extraordinary along the way. Until then, the hunt continues. But hold on, there lies something even more mysterious that mankind could not find the answers to. 5. What was the Great Attractor? Far out in space, there is something very strange pulling galaxies, including our Milky Way, toward it. This mysterious force is called the Great Attractor, and it has puzzled scientists for a long time. But what exactly is it? In the 1970s and 80s, astronomers noticed that galaxies near us were acting weird. Instead of just spreading out after the Big Bang as we'd expect, they were moving toward one specific area in space. And not slowly either. These galaxies, including ours, are speeding along at 600 kilometers per second. That's faster than anything we can imagine on Earth. Here's the tricky part. The Great Attractor is hiding in a spot that's tough for us to see. It's tucked behind the thick plane of our own Milky Way galaxy, which is packed with stars, gas, and dust. This area is called the Zone of Avoidance, and it blocks our telescopes from getting a clear view. And just when you think things can't get weirder, they do. The Great Attractor isn't a planet, a star, or even a single object. Nope, scientists believe it's a massive clump of mass that's warping space and time itself. But is it a giant cluster of galaxies? A supermassive black hole? Or something unknown? No one knows yet. This mystery has been puzzling scientists and keeping them curious and a little excited for decades. What's lurking behind this cosmic pull? Although the Great Attractor is hard to see, scientists have learned a few things about it over the years. Using special tools like X-ray telescopes, they can study the area around it and spot hints about what might be causing this enormous pull. The Great Attractor is located about 150 to 250 million light-years away in the direction of the Centaurus and Hydra constellations. That's incredibly far, but its pull is so strong that it affects galaxies over vast distances, including ours. Scientists believe the mass of the Great Attractor could be as much as tens of thousands of galaxies combined. Imagine all that in one place. One interesting clue is that the pull we're feeling isn't from just one single object. Nope, it's coming from a giant cluster of galaxies called the Norma cluster, along with other densely packed regions of space nearby. These clusters are absolutely packed with stars, black holes, and gas clouds, all jammed together so tightly that they create an incredibly strong gravitational pull. It's like a cosmic tug-of-war, and the Great Attractor is in the middle, pulling everything toward it. But here's where things get even more mind-blowing. The Great Attractor is likely just a tiny part of an even bigger structure known as the Laniakea supercluster. This supercluster stretches across a staggering 500 million light-years and, yes, includes our very own Milky Way galaxy. So, in the grand scheme of things, the Great Attractor is like the cosmic anchor within this vast network of galaxies, holding everything together. Pretty wild, right? Studying the Great Attractor is a bit like trying to solve a huge puzzle when half the pieces are missing. It's not easy. And why is it so difficult to learn more about this mysterious cosmic force? Well, the answer lies in where it's located and the tools we have to study space. The Great Attractor sits in a region of the sky called the Zone of Avoidance, which is a giant cosmic blind spot. This is the area where our galaxy, the Milky Way, is blocking the view. Imagine trying to see something through a foggy window. It's pretty hard to make out details with all that dust, gas, and stars in the way. Even our best telescopes struggle to peer through this galactic curtain. However, astronomers have clever ways to work around this problem. X-ray telescopes and radio telescopes can detect things that our eyes and regular telescopes can't see. Using these tools, scientists have been able to peek through the zone of avoidance and find galaxy clusters and other dense areas of mass that might explain the Great Attractor's pull. Still, it's tricky. The Great Attractor is far away, and light takes millions of years to travel from it to us. That means we're looking at it as it was millions of years ago, not as it is today. On top of that, galaxies, stars, and even space itself are constantly moving, making the study of such distant objects even more complicated. Despite the challenges, every small discovery brings us closer to understanding the Great Attractor. But here's the thing. Could there be something even stranger hiding behind it? After decades of research, the Great Attractor is still one of the biggest mysteries in astronomy. Scientists have found some interesting clues about what it might be, but the truth is, we might never fully solve this puzzle. Why? Well, because the universe itself is playing hard to get. For starters, it's hiding in the zone of avoidance, which is like the universe's version of a secret club. It's tucked away behind the Milky Way's thick cloud of stars and dust. Even with the most advanced telescopes, trying to spot the Great Attractor is like trying to find one light bulb in the middle of a sandstorm. And no matter how good technology gets, there will always be limits to what we can see in space. Then there's the problem of distance. The Great Attractor is so far away that the light we see from it today left millions of years ago. What we're studying isn't its current state, it's a snapshot of the distant past. By the time light from this region reaches us, the objects causing the gravitational pull may have moved, changed, or even disappeared entirely. Finally, the universe itself is in constant motion. Galaxies, clusters, and dark matter are all constantly shifting over billions of years, which makes it almost impossible to figure out exactly why the Great Attractor pulls things in. As scientists learn more, they often end up with more questions than answers. In the end, the Great Attractor shows us the limits of what we can know. It's a reminder that some mysteries in the universe might always be out of our reach. But maybe that's what makes it interesting. Knowing there are things we can't explain keeps us curious, keeps us exploring, and keeps us looking up at the stars. Oh, and speaking of space, ever heard about the scary incident that happened to a Chinese astronaut? Let's check it out. 6. Mysterious sounds heard. Imagine floating in the vast silence of space, thousands of kilometers above Earth, when suddenly you hear a sound. This eerie scenario isn't from a sci-fi movie. It's a real-life mystery faced by Chinese astronaut Yang Liwei during his historic Shenzhou 5 mission in 2003. Yang Liwei was the first astronaut sent to space by China, marking a monumental moment for the country's space program. But as he orbited Earth, he heard something entirely unexpected, a mysterious knocking sound. According to Yang, it sounded like someone was tapping the outside of the spacecraft, like hitting an iron bucket with a wooden hammer. Knock, knock, he described, coming and going without warning. The source of the sound was baffling. It wasn't from inside the spacecraft, nor could it have come from outside. After all, space is a vacuum where sound cannot travel. Yet the knocking persisted, sending chills down Yang's spine. After returning to Earth, Yang reported the incident to Mission Control. Engineers and scientists investigated but found no technical explanations. The spacecraft's instruments showed no irregularities, and the structure itself was intact. Was it thermal stress causing metal parts to expand and contract? Debris hitting the exterior? Or something more mysterious? Yang wasn't the only one to hear strange knocking sounds. Other Chinese astronauts reported similar noises during later missions, adding to the mystery. Despite thorough investigations, no one can figure out the cause. The knocking doesn't quite make sense, making space exploration feel even more mysterious. The knocking during the Shenzhou 5 mission got people's attention, sparking both curiosity and concern. Scientists, engineers, and space fans around the world started guessing what could have caused it. One of the most logical ideas is thermal expansion or contraction. In space, temperatures change rapidly, and when the spacecraft moves from sunlight to shadow, metals can expand or contract, making sounds that might seem like knocking. It sounds good in theory, but it doesn't fully match what astronauts like Yang Liwei described. He said the sound was distinct and rhythmic, something a little too musical for just metal shifting around. Another possibility is that space debris or micrometeoroids struck the spacecraft. These tiny particles move incredibly fast and can create sounds upon impact. However, the Shenzhou 5 showed no signs of damage after landing, and the knocking seemed to come from multiple locations, which makes this theory less convincing. Could it have been an auditory illusion? Space can play tricks on the mind. In the silence and isolation of space, even slight noises from the spacecraft systems might be perceived differently. But this theory doesn't explain why multiple astronauts on different missions heard similar sounds. Some people think the mysterious knocking in space might be linked to the spacecraft interacting with unknown space phenomena. The vacuum of space is full of mysteries, and honestly, we still don't fully understand how materials behave in such extreme environments. While this idea leans toward the unknown, it keeps the mystery alive. After all, no one explanation fits perfectly. For the astronauts who heard the knocking firsthand, it was unsettling but also strangely fascinating. Yang Liwei described it as rhythmic and deliberate, almost like something or someone was outside trying to communicate. He stayed calm, but the sound left him with questions that stuck with him long after he came back to Earth. What's even more interesting, other Chinese astronauts, or taikonauts, reported hearing similar sounds on later Shenzhou missions. The fact that this kept happening sparked debates among scientists, with some suggesting it could be a feature of the spacecraft itself. But for the astronauts, the knocking became a personal reminder that space is full of mysteries we may never fully understand. These reports also sparked wider public interest. Some linked the sounds to folklore and supernatural ideas, imagining space spirits or alien encounters. While these theories lack scientific backing, they highlight how mysterious events can capture the human imagination. After all, space has always been a source of wonder and intrigue. On a more scientific front, researchers from China's space program have continued to investigate the knocking. They've analyzed data from the Shenzhou missions, including structural tests and environmental factors, to uncover the source. Despite their efforts, no definitive explanation has been found, leaving the mystery unsolved. For the astronauts, the experience serves as a humbling reminder of the unpredictability of space travel. Despite extensive investigations, the question remains unanswered. But why is it so hard to explain? One major challenge lies in the environment of space itself. Space is a vacuum where sound cannot travel as it does on Earth. For a sound to be heard, it must originate from within the spacecraft or be transmitted through vibrations in its structure. This limitation rules out many potential explanations, but doesn't provide a clear answer. Another problem is the lack of direct evidence. People have heard the knocking, but no one has ever managed to record it. The spacecraft systems and instruments didn't show any issues, and everything seemed fine after each mission. Without actual data, scientists are left with just the astronauts' descriptions, and while those accounts are detailed, they can't give us the full picture. Time also makes it tricky to solve the mystery. The events happened years ago, and even though engineers are still studying the spacecraft's design and behavior, replicating the exact conditions of those missions is nearly impossible. Space travel is a unique environment, and some things might only happen in very specific situations that can't be recreated. Lastly, there's the reality that space holds secrets we may never fully understand. The knocking might result from an unknown aspect of physics or material science, or it could stem from something we haven't even imagined yet. This question remains unanswerable because it lies at the edge of our knowledge and technology. It serves as a humbling reminder that, for all our advancements, space exploration often leads us to mysteries as much as it does to discoveries. Sometimes, the answers may not be found, and that's part of the wonder of exploring the cosmos. Let's now look at another incident that took place in Ohio which shocked the whole world. 7. Wow! Signal. On a warm summer night on August 15, 1977, something extraordinary happened. At Ohio State University's Big Ear radio telescope, a scientist named Jerry R. Eman was scanning the skies for signals from outer space. Little did he know, he was about to stumble upon one of the greatest cosmic mysteries of all time. It would come to be known simply as the WOW signal. The Big Ear telescope was part of the search for extraterrestrial intelligence, SETI, a project dedicated to finding signs of alien life by listening to unusual radio signals. Radio waves are a great way to communicate across the cosmos. They can travel vast distances, unaffected by space dust or obstacles. The idea was simple. If intelligent life exists out there, maybe they'd try to send us a message. On August 15, 1977, the Big Ear telescope detected a strong, narrow-band radio signal unlike anything seen before. It was coming from the direction of the constellation Sagittarius, near a star cluster called Chi Sagittarii. The signal lasted for 72 seconds, then vanished. When Jerry Amon reviewed the data, he circled the signal's frequency on the printout and wrote a single word in the margin. Wow! The name stuck. The wow signal was powerful, much stronger than the background noise of the universe. Its frequency, 1420 MHz, was particularly interesting. This is the natural emission frequency of hydrogen, the most common element in the universe. Scientists theorized that if extraterrestrial civilizations wanted to send a signal, they might choose this frequency, knowing it would stand out. But here's the catch. The signal never repeated. Despite decades of searching, no one has ever detected anything like it again. Was it a message from an alien civilization, a natural cosmic phenomenon, or just a glitch? To this day, no one knows. The discovery of the wow signal sparked excitement and curiosity across the scientific community. Could this be the first contact with extraterrestrial life? Or was there a simpler explanation? Over the decades, many theories have emerged, but none have definitively solved the mystery. One popular theory is that the wow signal was a message from an intelligent alien civilization. The signal's strength, narrow bandwidth, and the use of the hydrogen line frequency, 1420 MHz, made it seem intentional. Hydrogen is a universal element, so some scientists argue that a technologically advanced species might use it as a cosmic beacon to communicate. But skeptics have other ideas. Some believe the signal could have been caused by a natural cosmic event. For example, certain celestial phenomena, like pulsars or quasars, emit powerful radio waves. Could the wow signal have been a rare natural burst of energy from deep space? So far, no known object fits the characteristics of the signal. There's also the possibility of human interference. Radio signals from Earth, like those from satellites or aircraft, can sometimes mimic extraterrestrial signals. However, the Big Ear telescope was designed to filter out local interference, making this explanation less likely. One of the most intriguing investigations involved examining the region of space where the signal originated, near the constellation Sagittarius. Scientists have pointed their telescopes back to this area multiple times, hoping the signal would repeat, but it never has. This lack of repetition is a major challenge in confirming its source. In 2017, researchers proposed a new theory, the wow. The signal might have come from a passing comet emitting natural radio frequencies. This explanation gained some traction, but it's far from conclusive. The most frustrating part of the wow signal is its elusiveness. For scientists to confirm the source of a radio signal, it usually needs to be repeated. But the wow signal hasn't shown up again, leaving astronomers scratching their heads for decades. What makes this even more puzzling is that the search hasn't exactly been half-hearted. After the signal was first detected in 1977, astronomers quickly turned their telescopes back toward the same region in Sagittarius. They scanned the skies repeatedly, hoping to hear the same frequency again, but silence greeted them every time. The Big Ear telescope itself continued scanning the area for years after the event, but found no similar signals. In the decades since, other advanced radio telescopes around the world have taken up the hunt, from the Arecibo Observatory before its collapse to more recent SETI initiatives. Astronomers have tried everything from narrowing the search field to increasing sensitivity. Still, the 1420 MHz signal remains a one-time wonder. This lack of repetition has fueled endless speculation. Was the signal just a freak occurrence, like a cosmic hiccup? Did it originate from a source that moved out of range or no longer exists? Or, as some suggest, could it have been an intentional message sent once and never repeated? Adding to the complexity is the idea that if the signal came from an intelligent civilization, it might have been sent long ago. Even at the speed of light, signals from distant stars can take thousands or millions of years to reach us. By the time we hear them, the sender could be long gone. Despite these challenges, the wow signal has inspired new ways to search for extraterrestrial life. Instead of waiting for signals to repeat, scientists are now exploring patterns and anomalies in existing data, anything that could hint at intelligent origins. Decades have passed since that fateful day in 1977, and the wow signal still stands as one of astronomy's most tantalizing mysteries. Despite countless efforts, we remain no closer to a definitive answer about its origin. Why has this question remained unanswered, and why might we never know the truth? One major challenge is the nature of the signal itself. It lasted only 72 seconds and was never repeated. In science, repeatability is key to confirming a discovery. Without another instance of the signal, it's impossible to conduct further observations or validate any theories. It's like hearing a whisper in a crowded room and never finding out who spoke, or even if anyone did. Another reason is the vastness of space. The WOW signal came from a tiny patch of sky in the direction of Sagittarius, but that area contains millions of stars, potentially billions of planets, and countless unknown phenomena. Pinpointing the source of a single fleeting signal amidst this cosmic complexity is like searching for a needle in an infinite haystack. There's also the possibility that the signal was unique, a one-time event caused by something we don't yet understand. Whether it was an intentional message, a natural phenomenon, or even an equipment anomaly, the conditions that created it might never occur again. If the source has since moved, changed, or ceased to exist, we may never have the chance to study it further. Ultimately, the WOW signal highlights the limits of our knowledge and technology. We've only just begun to explore the universe, and much of it remains beyond our reach. While the signal might forever remain a mystery, its impact on humanity is undeniable. It has inspired generations of scientists, dreamers, and explorers to look to the stars and wonder, are we alone? Perhaps the greatest legacy of the WOW signal is its reminder of the unknown. Sometimes the universe whispers its secrets, briefly, tantalizingly, but leaves us with more questions than answers. And maybe that's what keeps us searching.